So, don't make products that are toxic to human health. Don't make products that are toxic to the environment. Okay, there are some things that don't affect humans at all, very, very damaging to the environment. Okay, some chemicals have very different effects on different species. So, for instance, you will take ibuprofen, it's either ibuprofen or paracetamol. Paracetamol for headaches, but it's fatal to cats. Okay? Cats can't process paracetamol at all. They take a paracetamol tablet, they die. Okay?
I'm actually going to try that.
It's either, I'm pretty sure it's paracetamol, it might be ibuprofen, but one of those two, totally harmless. Thank you. It's not totally harmless to humans, because in quantity they'll kill you both. But both of them will kill you. But one of them is fatal to cats, in even small doses. So, don't make products that are toxic to the environment. This one here, reduce the energy requirements of the process. It's very, very important. Okay? Wherever you've got energy being used, the majority of electricity is produced from fossil fuels. Okay? So where you have energy being required, you have fossil fuels being used, and there is a carbon footprint of that energy. Now there are some exceptions. So for instance, Anglesey Aluminium gets all its electricity from Wilver Power Station, which is nuclear. So that is actually very low carbon aluminium. Okay? There's aluminium that's produced in Ghana that comes from hydroelectric electricity, and so on. Use alternative energy resources. Okay? If you have a windmill powering your plant, it's got less of a carbon footprint than if you're getting your electricity from a coal-fired power station. Use renewable resources, raw materials, not finite resources. Okay, so anybody that's able to make plastics out of vegetable oil and so on, that is not a finite resource. We can carry on doing that. Catalysts. You know that catalysts speed up rates of reaction. Okay, we've talked about how they, or we might not have talked about how they do it. A catalyst doesn't just increase it by a factor of 1 or 2. Iron in the Haber process increases the rate of reaction by a factor of 30,000. Okay? It produces as much stuff in 1 second as it would take 8 months to do without the catalyst. Okay? That's the difference that a catalyst makes. Waste products should be designed to be biodegradable. If all your waste product can just go into the atmosphere and break down without causing any damage, that's fantastic. Much better than one that goes up and destroys the ozone layer. And finally, you need to reduce the risk of explosions and fires. Okay? Sometimes chemistry is done in a certain way just to make it more safe to do. A good example from GCSE, this GCSE chemistry, not double award, would be the contact process and the manufacture of sulfuric acid. If you remember, the sulfur trioxides dissolve in sulfuric acid to form oleum, which is then diluted. You could have just dissolved the sulfur trioxide in water, but you get explosions, you get a very violent reaction. So it's done a slightly different way, overall same effect, but it's safe. Okay, it's a no-brainer. You do it the dangerous way, you do it the safe way, you're going to do it the safe way. But these are all things to consider when it comes to choosing which way to do the reaction. So, recycling. I don't need to tell you what recycling is. You know what the recycling is. You know why it's good. All of these things and so on. I don't think there's anything there that you don't know about. Okay, but any of that could come up. Renewable resources can be replenished by natural processes. They're replaced at a rate in which they can be produced. Okay, so I was watching a program the other day which was talking about Christmas trees. And they were saying they've got an 8-year cycle. Okay? That was a renewable resource. They were able to generate Christmas trees on an 8-year cycle. They'd chop an eighth of the Christmas trees down each year. Okay? Plant new ones, and by the time they'd finished the cycle, they could get back to the beginning, they'd got new Christmas trees. Does that make sense? 8 plots of land, and so on. They could, if they wanted to, not sell those Christmas trees to be Christmas trees. They could sell them to a wood-fired power station, and then you have a renewable source of energy. Okay? Often do not contribute to global warming. That's a bit of a contentious one. Things like biofuels, people go, oh, they're great, you know, they don't come from fossil fuels. no carbon footprint. Not true. Okay? If you've got normal diesel used for agriculture, if you're powering your tractors with normal diesel, if you're using artificial fertilizers, there's a carbon footprint attached to those. Okay? And so it's not true they don't contribute to global warming. They contribute less to global warming, but it's very hard to get anything from the ground that is carbon neutral. Often far more environmentally friendly and lead to more sustainable use of materials. Sustainable development. Okay, let's just quickly write a definition for this one. This is in the AQA Double Award GCSE. We welcome them. What is the sustainable development? It is development that does not harm the prospects of future generations. So, say again?
What was that again?
It's development that does not harm the prospects of future generations.
Thank you.
If in your lifetime all the oil gets used up, your grandchildren's grandchildren are not going to have any oil. And that is not sustainable development. Whereas, okay, areas of land, if they're farmed well, will still be producing food in the lifetime of your grandchildren's grandchildren. Make sense?
Yeah.
So you've got the difference between sustainable and unsustainable development. Renewable energy, yawn. Moving on. CFCs.
Yeah.
We talked a bit about CFCs anyway. Let's talk about why they're created in the first place. Because CFCs is one of those things you hear and it's like, it's all bad. CFCs are bad, they're terrible, and so on. Well, in actual fact, they were created in 1928 as non-toxic, non-flammable refrigerant. That's a pretty good idea. Up till then, refrigerants were either flammable or toxic. Okay? Along comes Mr. CFC, makes CFCs, and goes, this is fantastic. Uses solvents, they use in air conditioners, low reactivity and volatility. You can actually breathe them in small quantities. You breathe them in, breathe them out. Some of them, not a lot of them. Something like sulfur hexafluoride, which is not a CFC, but it's SF6. Should you look on YouTube, you will find videos of people breathing the stuff. And you know how helium makes your voice very high? Sulfur hexafluoride makes your voice very low. Still not a good idea. But they're very low reactivity. However, as you all know, UV light in the upper atmosphere easily breaks the CCl bond. Free radicals form, speeding up the depletion of the ozone layer. And this is the wrong set of equations. Okay, just put a light. Actually, no. That equation's fine. We change this one, don't we? ClO dot plus O3 goes to 2O2. ClO dot plus O3 goes to 2O2. That's your AQA chemistry for that one. It's a slight oversimplification, and you should be aware that you will see a different oversimplification for any materials that are prepared for the OCR syllabus. Okay. Biofuels. Ethanol is used as a biofuel. It's made from crops, e.g. corn and sugar cane. Takes in carbon as carbon dioxide from the atmosphere. When burnt, it releases the CO2 back to the atmosphere, but the carbon came from the atmosphere in the first place, so it's got to be carbon neutral, right? Wrong. Energy is required to plant and harvest, converts plants to ethanol. Fertilizer and pesticides used are pollutants, and so on. Okay? So it's not completely environmentally friendly. It might be more environmentally friendly, but it's still not completely environmentally friendly. Could destroy natural habitats and reduce biodiversity. At the moment, people are cutting down virgin rainforest to grow biofuels. Okay? It's an untouched rainforest. Shut up, all of you. Plastics and polymers. They're good. I mean, plastics are great. Plastics are fantastic stuff. I've waved my trusty lightsaber around. Lots of different plastics here. Mostly chemically inert. Once the plastic's formed, it doesn't then react. Mostly non-toxic, though don't try eating them. Waterproof, easy to mould. Non-biodegradable. Why is that a good thing? Yeah, you know, the guttering on my house is plastic. I'm glad it's not biodegradable, okay? Because if it was, it wouldn't be much good at holding rainwater for any long period of time. Lightweight, okay? Replaced the guttering on my house. It used to be cast iron stuff. It was very heavy. Okay, the stuff that I replaced it with, light, non-biodegradable, will hopefully last 30, 40 years. Bad, because they're made from crude oil. This lightsaber came from crude oil. Non-biodegradable, so take hundreds of years to decompose. Okay, that's the flip side. Non-biodegradable is good because they last long, and it's bad because they last long. Yes? A lot of energy is used in the formation, can form toxic products during incineration or any other disposal. Disposal in landfill sites is a waste of resources, environmentally unsound, and takes up valuable space. Okay? So plastics are great, apart from their manufacture and getting rid of them. Catalysts. Can give a better atom economy? No, they can't. Put a line through that one, please.
Catalyst or a catalyst. There.
They do, however, lower the energy required for reaction to take place. They don't lower the activation energy. They provide an alternate pathway with a lower activation energy. There is a difference and you're expected to know it. Okay, we'll revisit that in a little while. So they do reduce the CO2 emissions. They don't give a better atom economy because the reaction is still the same one. They just make it occur faster. The Kyoto Protocol's been in the news recently because everybody's going to Copenhagen. I think that's in a few days' time, isn't it? The Copenhagen conference?
Yesterday.
Sorry?
Yesterday.
A week yesterday. So on Monday then.
Yeah.
Monday? If I understood it correctly, the Copenhagen conference is the sort of the big follow-on from the Kyoto Protocol. The Kyoto Protocol was essentially an agreement between a number of nations to reduce their emissions of these things. Primarily carbon dioxide, but also methane, HCFCs, perfluorocarbons, okay, that's many fluorocarbons, and finally, one I mentioned earlier, sulfur hexafluoride. Okay, these chemicals are all destructive in some way. The top two are greenhouse gases, and these three are also greenhouse gases, but they also contribute to ozone depletion. Perhaps to a lesser extent, but they're all greenhouse gases, and so on. Some countries agreed to make larger cuts. Developing countries were not required to cut their emissions. And this is sort of one of the key contentions in it, that some countries were required to massively reduce their cuts, their emissions, whereas other countries were allowed to carry on increasing their emissions. Now, you don't have to be an economist, and I'm certainly not, to appreciate that makes some countries economically more competitive than the others. Okay? Bottom line, if you have a larger manufacturer in the US, okay, and that manufacturer has to pay for their carbon emissions, and you have a similar manufacturer in China that does not have to pay for their carbon emissions, who is going to produce the cheaper products?
China.
Exactly. And so on. The US didn't sign up, it would have significantly affected their economy. If they were having to reduce their carbon emissions, they felt their goods would become uncompetitive compared to the goods produced in other countries. So, problem was, without the US support, because they're the largest emitter of greenhouse gases, a lot of people felt that it wasn't a valid treaty or wasn't enough of a treaty. Countries such as India and China, going through great industrial change, did not have to cut emissions. And according to a lot of scientists, the cuts weren't big enough. Okay? The Kyoto Protocol wasn't perhaps the greatest treaty ever signed, but it was an attempt. It was a step in the right direction, and it was now 12 years ago. But Copenhagen next week is hopefully going to be another step in the right direction. And that is the end of green chemistry. Are there any questions about that? No? Okay, if we can pause there, please. Right, definition for you. In the syllabus, it says that carbon neutral refers to, and then in quote marks, so write this one down.
Oh, wait there.
This is the syllabus definition of carbon neutral. It says, an activity that has no net annual carbon emissions to the atmosphere.
That's written down in
Is it word for word in the...
the... Yeah.
Great.
Boom.
It then says, know the importance of these alcohols as liquid fuels, and that methanol made by this process can be a carbon neutral fuel. Okay, the syllabus wants you to know that methanol can be considered a carbon neutral fuel, okay, but only if the processes of manufacturing the methanol from the cornstarch and so on are themselves carbon neutral. Okay, so if you've got carbon neutral fertilizer, if you've got carbon neutral diesel going into your tractors, and where the tractors are made, you've got a carbon neutral plant, fat chance, then you've got a carbon neutral fuel. Couple of other quick things.
50.
There's the environmental aspects of metal extraction. So you need to understand the environmental and economic advantages and disadvantages of recycling scrap metals compared with the extraction of metals. Okay, so the principal advantage of recycling aluminium is that it uses much less energy to recycle aluminium than it does to manufacture it in the first place. About the fifth of the amount, 5% of the amount of energy required to manufacture aluminium is required to recycle aluminium. Okay? But with glass, you have to make much thicker bottles if you're going to recycle them. Okay? And if a bottle's not reused at least 3 or 4 times, then it would be better to actually make single-use bottles and throw them away. Okay? If you have to make, if you make a recyclable glass bottle and then that gets thrown away after the first use, that's a waste of energy. So then you've got issues of collection and so on. I understand the environmental advantages of using scrap iron to extract copper from aqueous solutions compared with high temperature carbon reduction of copper oxide. Pause for a second, please. A very small bit of the syllabus, okay, that you will not find in any past question. And we've already covered the manufacture of metals, or the extraction of metals. The syllabus says, understand the environmental advantages of using scrap iron to extract copper from aqueous solutions compared with high temperature carbon reduction of copper oxide. Basically, if you can use the blast furnace process to extract copper, and that works very well. But you need very pure copper oxide. If you have a very low quality ore, what you can do is you can dissolve the copper into solution. Ollie, can you pause please? If you have a low grade copper ore, what you can do is you can react it with an acid, okay, and get the copper into solution. So you can get very low quality copper sulfate solution or something like that. Does that make sense? Okay? What you can then do is take scrap iron and put the scrap iron into your low grade copper solution. Now you should know from year 8 chemistry that iron is more reactive than copper, and the iron will displace the copper. And the iron will go into solution and the copper will form on the surface of the iron. Remember doing that experiment in year 8 where you put the iron nail into a blue solution and it goes all nice and copper coloured?
Yeah, boy.
Yeah? Do that on an industrial scale. You can use scrap iron, low grade copper ore, and you can make copper, which makes everyone happy because copper's really, really expensive. Know that the usual source of such aqueous solutions is low grade ore. It says that in the syllabus. Low grade ore, get it into solution, chuck in a bit of scrap iron, you get copper out. Much, much better than purifying the ore, refining the ore, and then chucking it into a blast furnace. We've done all of that. We've done all of that. It does say about CFCs that legislation to ban the use of CFCs was supported by chemists, and they have now developed alternative chlorine-free compounds. Okay, a new fridge will not have CFCs in the back of it. It will have butane and other gases in the back of it. Okay, because a fridge primarily works by compressing and then vaporizing gases. Okay, so you need gases in a fridge for a fridge to work. Okay, it's also why you can't just throw away an old fridge. An old fridge is likely to contain CFCs, okay, and they have to be taken to the tip to be disposed of properly. Okay? And apart from that, we looked at alcohols last week, and we did say then you had to compare the production of alcohols by fermentation with the direct hydration of ethene. Remember, there were two ways of doing it. You can make it via fermentation, you can make it industrially, and you have to be able to compare and contrast those two. But apart from that, I think we're good for green chemistry. Okay, stop there please.